Welcome to the last part of section 6.7, applications. So we're going to talk about how we can apply what we've learned about how to solve equations by factoring. So to understand this again means we're going to deal with word problems. So we're going to deal with them. So here is a word problem. Now before you start jumping up and down and freaking out about it, which for any word problem I encourage you to breathe, look through it and ask yourself, what are you looking for? So just like the general strategy we've looked at before. What are we looking for? Well, we're looking for how long will it take for an object to hit the ground. Long, that means we're looking for some kind of time value. So we're looking for some time. Now, we go through and look at what's the other piece of information. Well, notice I'm given an equation here, h equals, where h is the height of the object after t seconds. Okay, so let's use that our equation. So, but notice we want to know when it hits the ground. That means the h is 0. So if I substitute that in, I get this equation. Now that looks like something we've dealt with in this chapter before. So can you pause, if using all this we've done in this chapter already in 6.7, can you pause and can you solve that equation by factoring? Go ahead. Welcome back. Hopefully, the first thing you saw was as you approach this problem is that I can factor out the greatest common factor. What is the greatest common factor? It's -16. And if I do that, I have a much easier polynomial here in t squared minus 3t minus 10 to factor out. So this is the solving process. Remember our strategy. What am I looking for? What do I know? How do they relate? So that's h equals 0 and setting up the equation. Now we're solving it. Well, we can factor this thing, and indeed it factors into t minus 5 and t plus 2. Now, you can set all those factors equal to 0. Notice I didn't set -16 equals 0 because, well, it's never going to equal 0. But if there was a t out there, I'd have to deal with that possibility. Now we have these two times, t minus 5 equals 0 or t plus 2 is equal to 0, which come out to be t is equal to 5 or -2. Well, what is t again? Going back up to the word of the question, the wording, it says that t is seconds. Well, does it make sense to have negative time? Unless we have a flux capacitor, no, it's impossible. So since we cannot have negative time, our only answer is it will take 5 seconds to hit the ground. So this goes back to that last part about units and checking our answer and does it make sense. Just solving it isn't enough. You really need to ask yourself, because sometimes you get these extraneous answers that really don't make sense in that particular real world scenario. So always think about time. Can't be negative. Can you have a negative height? Well, actually, technically you could, because you could be below the ground. Death Valley has a negative altitude. So not everything negative is thrown out. So it all depends on the specific scenario that we're dealing with. So read the question, ask yourself, what are you looking for? What do you know? And how are these things related? Then solve the problem. Hint, this section 6.7, you're going to factor. And then ask yourself, does that make sense? So you may trim down your answers. Let's do another example to kind of demonstrate this one more time. So I want you to take a moment and ask yourself, what are the things I'm looking for? And what am I given? Go ahead. All right. As you did that, hopefully you realize you're looking for the dimensions of a rectangle. Well, those are length and width. What's the other information I'm given? Well, we're told that length is 2w minus 8. It's twice the width minus 8. Or 8 inches less than twice the width. Same thing. That's valuable information. I'm also told that the area is equal to 90 square inches. That makes sense. But we're dealing with a rectangle, so what's the formula for the area of a rectangle? Well, it's length times width. Now notice, can I substitute in something for my area? Can I substitute something in for my length? And if I do that, I have an equation that has one variable that I can solve. So I want you to pause the video, go ahead and solve that particular equation by factoring. Welcome back. Hopefully you already did your factoring, and then you also recognize which of your answers are correct. So as we work through this, hopefully you distributed the W, because remember, and then you have to remember I have to get it equal to 0, so I have to move everything to the other side. So I have to have it equal 0 before I can factor, because that is what the zero product rule is all about. Well, if you look at this, notice you can pull out a greatest common factor, 2. Pull that out, that's a much easier polynomial to factor. Specifically, I can factor into W minus 9 and W plus 5. If we solve each of those, we end up with two answers. W is equal, the width is equal to 9, or the width is equal to negative 5. Again, a negative width doesn't really make sense, so we're going to go with a positive width. But we're not done, because notice it asks for the length and the width. So how could you find the length if the width is 9? Hopefully you're saying I can plug it back into what I already have. So the length is 2 times 9 minus 8, or 18 minus 8, or 10 inches. So our answer is the length will be 10 inches and the width would be 9 inches. So hopefully that kind of helps you understand how to set up these problems. Work through them, but use the general questions we've asked before. What am I looking for? What do I know? How are these things related? After you solve, remember to ask, does that make sense? What kind of units am I really dealing with? To make sure everything is working together. Please let me know what questions you have, and good luck with your homework.